Hey guys, this is 5.7. We are going to talk about dividing a polynomial by a monomial. So last time we were multiplying, now we are dividing. After this, we go on to chapter 6 in the book. It's still the same unit, but it's chapter 6, and that will be about factoring. So it will be related to dividing polynomials by monomials because we'll be trying to factor something out of different terms. All right, let me pause this and switch to the document camera. All right, it is focused. Hopefully it's big enough, and hopefully I stay close enough to the microphone and keep everything, or keep the what I'm writing in the frame. That should be a goal. All right, so 5.7 is dividing polynomials by a monomial. It looks like fractions. Remember, fraction just means division. There is a rule. So remember way back when we were doing fractions, so like the first two lessons of this course, we were saying that if you are adding, if you are adding fractions, you want the fractions to have the same, this is the numerator, and the bottom part's the denominator. If you're adding fractions or subtracting fractions, you need them to have the same denominator. So this one has a denominator of C, this one has a denominator of C. We're adding them together. So all we do is we keep C, we keep the denominator, and we combine the two terms on top of the C with the same sign that was between them in the equation. So we went from this expression to a single division problem. Right? So we're saying A divided by C plus B divided by C equals A plus B divided by C. Kind of like we're just putting a parentheses around them, but it has to be that the denominator is the same. That was from fractions. What we're going to do when we're dividing polynomials is we're going to apply this principle in reverse. So this principle would be like 1/4 plus 1/4 equals, the 4 stays the same, 1 plus 1 is 2, right? Which then we would simplify into 1/2. But that's what we're doing, okay? Down here, we are going to split the dividend, or the top, into its separate components and divide each by that same monomial. So we can take A plus B equals A plus B divided by C and call it A divided by C plus B divided by C, which is exactly the same as what we had over here, right? Okay, so our first example is negative 24x squared minus 16x plus 32 all divided by 8. Okay, what we're going to do is we're going to change it from A plus B divided by C to A divided by C plus B divided by C, and then we're going to simplify each of the three, because we'll have 3 parts then, right? We'll have 1, 2, 3. We'll simplify each of those 3 parts. Always remember that if you have a negative, if we have a minus sign, that becomes a negative when we're making the, well, I guess it doesn't have to be. Like you can just put a minus between them. But remember that minus 16x is the same as plus negative 16x, right? Okay, so negative 24x squared divided by 8. Okay, now we're just simplifying a fraction, right? If I was to take negative 24 and I was to, well, does it divide by 8? That's always something to try. Negative 24 divided by 8. If it gives you a whole number, perfect. It does. Because negative 24 is also negative 3 times a positive 8. Right? And then when we cancel out those 8s, we get negative 3, which is just what we're doing here, right? Because we change that negative 24 to a negative 3 times 8. We get the same answer. So we're doing what the calculator's doing, but I just showed you the steps the way I do it. So negative 24x squared divided by 8 becomes negative 3x squared. There's nothing in the numerator. Instead of negative 24 became negative 3. There's nothing in the denominator. So you can put a placeholder of 1, but remember anything divided by 1 is itself. So you can just call it negative 3 x squared. The x squared stays the same because there is no x's to cancel in the bottom. Good. All right, next piece is negative 16x divided by 8. And again, we can just say, can I put negative 16 divided by 8 into the calculator? That's perfectly legitimate. We get negative 2 because negative 16 is actually negative 2 times 8, right? Times x divided by 8 will cancel out factors that are common to the numerator and to the denominator. And we get negative 16x divided by 8 is negative 2x. Good. Our third term is a positive 32. So now I just have 32 divided by 8. Can I put that in the calculator? 32 divided by 8 is 4. Because 32 is 4 times 8 over 8. You can call it something else too. You could also call it, I could also say it is 32 divided by 8. If you wanted to put it into its prime factorization, 8 is actually 2 times 2 times 2, right? You can't get any simpler than 8 divided by 4 is 2. If I was going to make a factor tree, it would become 2 and 4. The 2 remains a 2. The 4 becomes 2 times 2, right? So those are the prime factors of 8. The prime factors of 32, if I just take 32 and start dividing it by prime numbers, 32 divided by 2 is 16. So that's a 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 2, 2, 2, and that 4 becomes 2 and 2. So if I take 2 times 2 times 2 times 2 times 2, I get 32. So you can also factor it even further than 4 and 8, right? You could say 4 is 2 times 2 and 8 is 2 times 2 times 2. If this is just for the future, if you're stuck and you don't know what to do. And then you can start canceling them. And what you get is there's nothing on the bottom, 2 times 2 on the top. 2 times 2 is 4. 4 over 1 is 4. Okay, so there are different ways to do it. In terms of factoring, if you see that you can take 32 and divide it by 8, do that because it's a bit more complicated, but it will work the same. Okay, so what we have here is our first term became negative 3x squared. Our second term became negative 2x or minus 2x, and then the 32 became positive 4, right? So when we simplify or when we divide negative 2x squared minus 16x plus 32 divided, if we divide that by 8, we get negative 3x squared minus 2x plus 4. Okay, let's do it again down here. Number 3, because that was number 1, was just the instructions. Number 3 is 21r to the 7th minus 35r to the 3rd divided by 7r. This is different because we are going to be dividing by both a 7, just like the 8, but also the letter r or the variable r. Remember the rule for simplifying is we're just putting it into its factored form. So the factored form of r is just r. The factored form of r to the 7th would be r 7 times, right? It is itself 7 times. Did I get that one? All right. So again, we're just going to split it into 2 terms. We have 21r to the 7th over 7r, and you're going to separate them. So you're going to do the numbers divided by the numbers, 21 divided by 7, and then you're going to do the variables, and it's not going to be, make sure you have the same variables. So the r is going to be divided by the r. Good. 21 divided by 7, if you put that into your calculator, it's just 3. But the 0 button's not the on button, so you have to turn it on. 21 divided by 7 is just 3. And then r to the 7th divided by r is, like we said, we have 7 r's. And down here, we just have r. So what I can do is cancel one of the r's. What am I left with? I've factored out all of the r's that are common to the numerator and the denominator, and I'm left with 21 divided by 7 is just 3. And then we have 1, 2, 3, 4, 5, 6 r's, or r to the 6th. So 21r to the 7th divided by 7r, it becomes 3r to the 6th. 21 is 7 times 3. The 7s cancel, so I get the 3. R to the 7th divided by r is just 7. Oh, you can even use the rule of exponents. R to the power of 7 minus 1 is r to the 6th, right? Okay, the second term of that was a negative, remember? 35 r to the 3rd over 7r. 35 divided by 7 is a 5 times 7, but it's a negative. So you can either make the 5 negative or the 7 negative. It's better to make the 5 negative so you can cancel a positive 7 with that positive 7. And then r to the 3rd means there are 3 r's. Don't forget the r down here, me talking to myself. And then I can cancel out the 7s and one of the r's. Anything that is common to the top and the bottom can be canceled. So that becomes negative 5r times r, or r squared, which is also r to the 3rd minus 1 is r squared. Good. So that's 3r to the 6th minus, because of that minus sign, 5r squared for number 3. Okay. Number 4, now we have x to the 12th on the top, x to the 4th on the bottom, x to the 8th on the top, x to the 4th on the bottom. You're welcome to subtract. So we can call this x to the 12 minus 4, or you can write it all out, right? X to the 8th minus 4, because when you're dividing the same base, you can subtract the exponents, right? That's the rule of exponents that we learned in 5.1 and 5.2. 8x to the 12th divided by 2x to the 4th. We can do it the long way. 8 is 2 times 2 times 2. And again, I found that by creating a factor tree, or you can even just Google what are the prime factors of 8. Not during an exam, so make sure you know how to do it, but that's the... Oh no. Right? 12. And then down here we have 4 of them. Good? All right, so 8 is 2 times 2 times 2. 2 is just 2. I can cancel out one of the 2's. 2 times 2 becomes 4. And then of all of those x's, I am left with 1, 2, 3, 4, 5, 6, 7. Doesn't seem right. 1, 2, 3, 4, 5, 6, 7, 8. X to the 8th, which is also possible by just saying 8 divided by 2 gives me that 4. And then 12 minus 4 gives me that 8. Right? 8 divided by 2 is 4. The rule of exponents says that x to the 12th divided by x to the 4th is x to the power of 12 minus 4. So make sure you have those rules of exponents out with you or in your head. Or you can do the long way. So that is going to be 4x to the 8th. And then we have a negative 14x to the 8th divided by 2x to the 4th. Negative 14x to the 8th divided by 2x to the 4th. Good. Negative 14 divided by 2 is just going to be negative 7 times 2. So I'm factoring the 14 by the number in the denominator if possible. So I have a 2 on the top and a 2 on the bottom, and I can cancel it. And then x to the 8th is going to be 8 x's, and then there's going to be 4 x's here. X to the power of 8 minus 4 is a faster way to do it. Okay. The 2 that is common to both the top and the bottom is eliminated, and we get -7. And then there were 8 x's up here and 4 x's down here. When we take away those 4 x's from the top 8, we get x to the 4th. -7 x to the 4th. Good. And as long as you don't have negative exponents, you don't have to do anything else. Okay. So we have a -7 here. We have a -5 here. We have a -2 here and a -3 here. As long as the exponent is not negative, you don't need to fix anything. Okay. It's not it doesn't need to change forms. It's only if the exponent is negative. All right. Number 5 says 30x to the 6 minus 25 x squared divided by -5 x to the 6. Okay, I'll do this one the long way. 30 is 5 times 6, but 6 is 3 times 2. And then we have x to the 6th. So you could say it's 5 times 6, or you could say it's 5 times 3 times 2. Good. You cannot say 5 and -5 cancel each other out. Okay. All of the 6's cancel each other out. X to the 6 divided by x to the 6th, those cancel out, but we can't say that 5 and -5 cancel each other out. So it's still 5 times 6 up here, or 5 times 3 times 2. But down here, it's -5. We can cancel out the 7 and the 7, right? Because 7 divided by 7 is 1. But -5 divided by 5 is not 1, it's -1. And 5 divided by -5 is also -1. What we need is for even the signs to be the same, and these signs are not the same. Okay? There are many ways you can deal with this. We have a problem. There are many ways to solve this problem. You could either say, so this was 30, right? This was 30, and we said 30 is 5 times 6 because we're looking for the same number as we have in the denominator. But how could I get 30 and divided by -5? Well, I could just say 30 divided by -5. 30 divided by -5 is -6. So instead of saying 30 is 5 times 6, we could say 30 is -5 times -6. Or we could keep those ones positive, the ones on the top, 5 times 6 divided by -5. And we could say, well, -5 is just -1 times +5, right? -1 times 5 is -5. -5 is -1 times 5. And in that case, you get 6 divided by -1. If we put that into the calculator, 6 divided by -1 is -6. Okay, so make sure the signs are the same. You cannot just cancel 5 and -5 are the same. You have to leave a -1 in the bottom or make the top negative by making them both negative. Okay, just watch the signs. It might be easiest to just do this. If I wanted this -5 to be positive, I'm going to make it the product of its positive self and -1. Okay, so all that to say, our answer is -6. 30 x to the 6 divided by -5 x to the 6 is -6. Good. Now we have -25 x squared divided by -5 x to the 6. negative 25 is the product of negative 5 and positive 5, right? And then here we have 2 x's. But down here we have 6 x's. Agreed? Negative 25 becomes negative 5 times 5. X squared becomes x times x. Negative 5 remains negative 5. X to the 6 becomes x times x times x times x times x times x, right? Okay. Cancel out anything that is common to the numerator and the denominator. The negative 5 and the negative 5 cancel. Good. This x and this x cancel. This x and this x cancel. And what I have is a 5 on the top, and then 1, 2, 3, 4 x's on the bottom, which is 5 divided by x to the 4th. Good. Faster way to do it with the calculator, is negative 25 divided by negative 5 is 5. And then x squared divided by x to the 6th is x to the power of 2 minus 6, which is x to the negative 4th. And x to the negative 4th now needs to be a positive. So we move it from the numerator to the denominator, the base, and the exponent becomes positive. So negative 25 divided by negative 5 is 5. And then when you're subtracting 2 minus 6, you get a negative 4. The negative 4 is up here, but then you move it down here to make it a positive 4. Okay. So we have negative 6, and then we have plus, right? Because the negative 5 and the negative 5 canceled, so we have a positive 5. So we have plus 5 divided by x to the 4th, because when you combine 5 times 1 divided by x to the 4th, you get 5 over x to the 4th, because we're multiplying them, right? 5 times 1 over x to the 4th is 5. That becomes 5 over 1, right? 5 times 1 is 5. 1 times x to the 4th is just x to the 4th. Number 6 asks us for negative 21x to the 6th minus 21x to the 4th minus 56x squared all over negative 7x to the 4th. So we're going to separate those into 3 different parts. Starting with negative 21x to the 6th over negative 7x to the 4th. Again, you're welcome to just put 21 by 7 into your calculator. Make sure you leave the signs the same. So negative 21 divided by negative 7. Not the natural log of that. 3, right? Positive 3, because negative 21 is actually negative 7 times positive 3, right? And then negative 7 is just negative 7. So when we cancel those out, we just get 3. And then over here we have x to the 6th. Down here we have x to the 4th. What can we cancel? We can cancel 4 of the x's that are common to the top and the bottom, the negative 7s that are common. And what we have left is the 3 and 2 x's. So 3x squared. Okay. You can also just say negative 21 divided by negative 7 is 3. X to the 6th divided by x to the 4th is x to the power of 6 minus 4, which is 3x squared. Next term is negative 28x to the 4th divided by negative 7x to the 4th. Negative 28 divided by negative 7. Positive 4. So negative 28 becomes negative 7 times a positive 4. 7's a prime number, so we just leave it as negative 7 in its factored form. And then each is x to the 4th. And we just say it's 4. It is also negative 28 divided by negative 7 is just a positive 4. And then x to the power of 4 divided by x to the power of 4 equals x to the power of 4 minus 4. So it's 4. X to the power of 4 minus 4 is just x to the power of 0. What is x to the power of 0? It's 1. 4 times 1 is just 1. So if you just want to use your calculator, negative 28 divided by negative 7 gives me 4. X to the 4th divided by x to the 4th leaves me with x to the power of 4 minus 4. 4 minus 4 is 0. X to the power of 0 is 1. 4 times 1 is 4. And then the last one is negative 56x squared divided by negative 7x to the 4th. Negative 56 divided by negative 7 is 8. Negative 7 times a positive 8 times x squared, which is just 2 x's, right? Negative 7 times 4 x's. Cancel out the negative 7s. We're left with 8. Cancel out 2 of the 4 x's, and we have 8 on the top and then x squared on the bottom. Or negative 56 divided by negative 7 is just 8. And then x squared divided by x to the 4th is x to the power of 2 minus 4. X to the power of negative 2. I don't want that to be a negative, so what I need to do is take just the x, just that base and exponent, and put it across the fraction bar. Just a little bit more practice with the negative exponents, and I get 8 stays on top, x squared stays on the bottom. So if you get a negative exponent up here, just move it down here. It will always work. Good. So that one was 3x squared plus 4 plus 8 over x squared. And that's exactly how to write it. Okay. All right. 2 more examples. This one is 32 x to the 6th, y to the 6th over 8 x squared y to the 4th. $32 divided by 8 is 4. Eight times 4 gives us that 32. 6 x's. And 6 my x's and y's look alike. I'm going to do a different color. 1, 2, 3, 4, 5, 6 y's. There's 8 down here. Times x, and then 4 y's. The 8's cancel. 2 of the x's cancel. 4 of the y's cancel. 4 on top, 4 on bottom. I know I didn't make that very easy to look at, but we have 4 x's remaining. Oops, sorry, we have the number 4 over here. 4 x's remaining, 2 y's remaining, and the number 4. 4x to the 4th y squared, and nothing on the bottom. Right? The 8 canceled, the 2x's canceled, and the 4y's canceled. Another way to do it is 32 divided by 8 in the calculator is just 4. X to the power of 6 minus 2, because it's division. Y to the power of 6 minus 4 gives me 4. X, 6 minus 2 is 4. 6 minus 4 is 2. Same answer. Next piece is negative 48 x to the third, y to the fifth. Over 8x squared, y to the fourth. Negative 48 divided by 8 is a negative 6, okay? So negative 48 is that positive 8 that we divided out of it times the 6, right? This times this will be this. Do you remember those, like, what were they called in elementary school? Fact families? 48 divided by 8 is negative 6. Negative 48 times negative 6 is 8, right? Or sorry, 8 times negative 6 is negative 48. Negative 48 divided by 8 is 6. It's supposed to be negative 6. It's supposed to be fact families, and I can't do it justice. All right, 8 times negative 6 times 3 x's and 5 y's. Right? And then on the bottom, we have that 8. And then we have 2 x's and 4 y's. What can we cancel? We can cancel the 8, the x, the x. We have 1 x left over, a negative 6. Y, 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 y. We have 1 y left over. So that is negative 6, 1x, 1y. Good. You can also just put it in your calculator. Negative 48 divided by 8 is going to be a negative 6 in the calculator. X to the power of 3 divided by x to the power of 2 is going to be x to the power of 3 minus 2, not 1. Y to the power of 5 divided by y to the power of 4 is going to be y to the power of 5 minus 4. Three minus 2 is 1. X to the power of 1 is just x. 5 minus 4 is 1. Y to the power of 1 is just y. So our first term was 4 x to the fourth y squared. Next term is negative 6 x y. The last one is 7 x squared y to the fourth. Divided by, and then it's going to be the same thing we've been dividing the other two by. 8 x squared y to the fourth. So this looks a little bit different, right? 7 is a prime number, so there's nothing that you can change 7 to. 7 is just 7 times 1, so we'll leave it as 7. X squared is just x times x. Y to the fourth is just, that's why I got to do it. They look the same. Those were the same. That was a mistake. 3, 4, right? Divided by, but 8, just to make sure, let's practice factoring 8. 8, if I was to make a factor tree of 8, it would be 2 times 4. 4 becomes 2 times 2. So 8 is actually 2 times 4 is one factor pair of 8. And then the prime factorization of 8 is 2 times 2 times 2. So 8 is actually 2 times 2 times 2. None of those is 7, so it doesn't really matter. Times x times x times y times y times y times y. 7 cannot cancel. 2 times 2 times 2. None of those 2's can cancel. Those x's cancel. And those y's cancel. That was a terrible drawing out of it. So we get 7 divided by 2 times 2 times 2, which we didn't even need to do, or 7 times 8, right? 7 divided by 8 in your calculator is not going to give you a whole number. Yeah, 7 divided by one of the factors of 8 is not going to give you a whole number. So you know you cannot factor that. So you just get 7 eighths, you leave that alone, x to the power of 2 minus 2 because it's x squared divided by x squared, and then y to the power of 4 minus 4. The 7 eighths remains the same. X to the power of 2 minus 2 is x to the power of 0. Y to the power of 4 minus 4 is y to the power of 0, which is just 7 eighths times 1, which is just 7 eighths. All right, guys, our last example. Oh, sorry. So that's plus 7 eighths. So there's our final answer. The 32x to the 6 y to the 6 became 4x squared x to the 4th y squared. Negative 48x to the 3rd y to the 5th became negative 6xy, and then plus 7x squared y to the 4th became plus 7 eighths because we divided it all by 8x squared y to the 4th. Good. All right. Last one, and this one looks like it has a lot of variables. And just like I was putting the x's and y's in a different color, you want to be thinking about the variables differently. So the a can only be simplified with other a's. The b is only simplified with other b's. And then the c with the other c's. Okay, maybe I'll just try to fit this one on the paper. So this one is a to the 4th, b to the 4th, c. No, I'm not. Divided by 2 a, b, c to the 4th. Again, we were doing numbers separately, right? So the 8 and the negative 8 and the 2, the 11 and the 2. There's no number here. You can also put a 1 if you want. Okay? So we can say that this is 4 A's times 4 B's times C on the top divided by the number 2, 1A times 1B times 4 C's. Good. Now we're just canceling things out. There's no number on the top, so I cannot cancel out the 2. You can cancel out one of the A's, one of the B's, and one of the C's. So now I have, for the A's, I have 3 A's. For the B's, I also have 3 B's. And then down on the bottom, I have the number 2, and then I have 3 C's. Okay. And I said you could leave it as a 1 up here, or you could add a 1 up here. So you could call it 1/2 a cubed b cubed c cubed, right? Or you could just say a cubed b cubed over 2c cubed. Because the 1 doesn't really change any, doesn't change the value of it. So that becomes a cubed b cubed divided by 2c cubed, right? Why? Because a to the 4th divided by a That's just a to the power of 1, b to the power of 1, c to the power of 1, right? A to the power of 4 divided by a to the power of 1 is a to the power of 4 minus 1. B to the power of 4 divided by b to the power of 1 is b to the power of 4 minus 1. C to the power of 1 minus divided by c to the power of 4 is c to the power of 1 minus 4. And we know the 2's down here because we can't factor it with anything. 4 minus 1 is 3. 4 minus 1 is 3 again. And then 1 minus 4 is negative 3. There's still a 2 down here because it was just down there. It's always been there. Now, because this is negative, I need to move it across the fraction bar, and I get a cubed b cubed over 2c cubed. Same answer. Next piece is negative 8 a b c to the 4th divided by 2a b c to the 4th. You can do it the long way or not the long way. Negative 8 is the same as negative 2 times a positive 2, which would be negative 4, times another positive 2, which would be a negative 8, times a times b times 4 c's. We agree? And then here I have a 2, which is already in its prime factored form. It's a prime number. 2 times a times b times 1, 2, 3, 4 c's. Now I'm just going to cancel things. Don't cancel it with the negative 2. Pick a different 2. That cancels, that cancels. Those cancel. So that becomes negative 2 times positive 2, which is a negative 4. Right? Or we say negative 8 divided by negative 2 is a negative 4. A divided by a is just a to the power of 1 minus 1. B to the power of 1 divided by b to the power of 1 is b to the power of 1 minus 1. C to the power of 4 divided by c to the power of 4 is c to the power of 4 minus 4, which is negative 4 times 1. A to the power of 0 is 1. B to the power of 0 is 1. C to the power of 0 is 1. So that's just negative 4, which is the same answer we had when we did it the long way. Right? That cancels, that cancels. Those are the same, so that cancels. Plus negative 8 a b c to the 4th divided by 2 a b c to the 4th is negative 4, or minus 4. And then we have 11 a to the power of 5 b to the power of 7. 11 is a prime number, so we can't factor it. So we're just going to leave it as 11 times 5 a's, 7 b's, and then 4 c's. Good. 11 divided by 2 just remains 11 over 2. That a cancels, that b cancels, none of the c's cancel. So we have a to the power of 1, 2, 3, 4. B to the power of 1, 2, 3, 4, 5, 6. C to the power of 4. Or in the calculator, again, 11 divided by 2 is just the fraction 11 halves. A to the power of 5 minus 1. B to the power of 7 minus 1. And then C to the power of 0 minus 4. a to the power of 5 minus 1 is a to the power of 4. B to the power of 7 minus 1 is b to the power of 6. And then c to the power of negative 4, which is 11 positive exponents up here. 2's down here. And then the negative exponent becomes a positive by moving down to the denominator. All right, guys, that is it for 5.7. Thanks so much. I'm gonna stop it now. Have a great day.